Hello students, myself XI-Sci Gorane from XI-Sci RBNB College Srirampur. Today we study chapter from 11th Science, Electromagnetic Waves and Communication System. This is my first lecture on this topic. Firstly, see the introductory part. You know about wave. An oscillatory disturbance traveling through the medium without change of form is wave. And we know there are two types of waves, that is transverse wave and longitudinal wave. In transverse wave, the particles of medium vibrates in a direction perpendicular to the direction of propagation of wave. We know light waves are the transverse waves, and in longitudinal wave, second type of the wave is longitudinal wave. Particles of medium vibrates in a direction parallel to the direction of propagation of wave. The waves are longitudinal wave, and we know that sound waves are longitudinal wave. Now we also know about the electric field. Electric field is produced by the charge at rest. If charge is at rest, there is certain space around this charge in which another charge experiences a force. We call it as an electric field. Electric field is produced by the charge at rest, whereas magnetic field is produced by the charge in motion. Charge in motion, we call it as a current. When current flows through the conductor, magnetic field is produced around it, or a magnet also produces a magnetic field around it. The strength of this electric field is expressed in terms of electric intensity, and strength of the magnetic field is expressed in terms of magnetic induction. So steady charge produces the electric field. If charge is in motion, it produces a magnetic field. We use various devices or gadgets such as television, cell phone, internet. In these devices, we use the waves called as electromagnetic waves. Electromagnetic waves as a carrier of transmission of signals. The signals are transmitted in these devices, that is cell phone, television, internet. Electromagnetic waves are used as a carriers of signals or transmission of signals. The light from the sun, that is energy from the sun, reaches the earth in the form of electromagnetic waves. X-ray machine produces X-rays. These X-rays are nothing but the electromagnetic waves. Radioactive materials such as uranium, thorium, they emit some radiations in the form of gamma rays. These gamma rays are also electromagnetic waves. Now we see what is this electromagnetic waves and how they are produced. Very interesting concept, electromagnetic waves and how they are produced. These electromagnetic waves. We know electric charge at rest produces electric field. Charge at rest, it produces an electric field, but it does not produce a magnetic field. Charge at rest produces the electric field but not magnetic field. When charge moves, we call it as a current. When charge is at rest, it produces only electric field, but when charge moves, it produces both electric and magnetic field. both electric and magnetic field are produced. At rest it produces only electric field. When it is in motion, we call it as a current, and it produces both electric and magnetic field. If it moves with constant velocity, if charge moves with constant velocity, magnetic field does not change with time. Magnetic field not changes with time. Charge moves produces both electric and magnetic field. But if the motion of charge or charge moves with constant velocity, magnetic field will not change with time. Hence, EM waves are not emitted. Electromagnetic waves are not emitted. Why? Because charge moves with a constant velocity. Magnetic field does not changes with the time. But if charge is accelerated, we know the accelerated motion. What happens if charge is accelerated? Both electric and magnetic field, that is E and B, changes with time. Both E and B changes with time if the charge is accelerated and electromagnetic waves are produced. It means the accelerated charge produces electric and magnetic field which changes with time. Electric and magnetic field which changes with time, and electromagnetic waves are produced due to the accelerated charge. That is, the oscillating charge produces the electromagnetic waves which has same frequency as that of oscillation of charge. Oscillating charge produces the electromagnetic wave which has the same frequency as that of oscillation of the charge. It means in electromagnetic waves that are caused by the acceleration of charged particles and consist of electric and magnetic fields vibrating sinusoidally at right angles to each other and to the direction of propagation of wave, such waves are electromagnetic waves. Electromagnetic waves are the waves which are produced due to acceleration of charged particles. It consists of electric and magnetic fields. These both fields are perpendicular to each other and also perpendicular to the direction of propagation. Such waves are electromagnetic waves, and the waves are produced due to the accelerated charge, or the oscillating charge produces the electromagnetic wave. Now we see the electric and magnetic fields which are perpendicular to the direction of propagation in this diagram. Suppose electromagnetic wave travels along the x-axis, positive x-axis. This is y-axis, and this perpendicular axis is suppose z-axis. Suppose wave is traveling EM wave propagating along the positive x-axis. Here electric and magnetic fields are there, and they are perpendicular to each other and also perpendicular to the direction of propagation. This is EM wave propagating along x-axis. Electromagnetic wave propagating along x-axis. The electric field is along y-axis. These are the electric fields along y-axis. We denote it by EY, positive Y, negative Y. Electric field vectors along the y-axis, and magnetic field along the z-axis. This is BZ. We call it as BZ. Electric field along y-axis, magnetic field along z-axis. This is the magnetic field. See here, the electromagnetic wave is propagating along the x-axis. Electric field along y-axis, electric field, that is E, here along y-axis, and magnetic field, that is B, along z-axis. We know that these axes are perpendicular to each other, x, y, z. These axes are perpendicular to each other. Here the wave is propagating along the x-axis. In electromagnetic wave, we know electric field and magnetic fields are perpendicular to each other and also perpendicular to the direction of propagation. Here electric field is along y-axis, denoted by EY, and magnetic field is along z-axis, denoted by BZ. So these are the magnetic fields. Both fields are perpendicular to each other and also perpendicular to the direction of propagation. This wave, we call it as an electromagnetic wave. Electric and magnetic fields are perpendicular to each other, also perpendicular to the direction of propagation. Consider the charge oscillates or accelerates with some frequency, and this charge produces oscillating electric field. Oscillating charge produces the oscillating electric field in space, which produces the oscillating magnetic field, and this oscillating magnetic field in turn is a source of oscillating electric field. Oscillating electric field produces the oscillating magnetic field, and oscillating magnetic field is a source of oscillating electric field. It means the changing electric and magnetic fields regenerates each other. Changing electric and magnetic fields regenerates each other. Here, this is the direction of propagation. Along this x-axis, direction of EM wave. Along this axis, there is electric field. Along z-axis, there is magnetic field. These oscillating electric and magnetic fields regenerates each other, and electromagnetic waves travels through the space or through the medium. In electromagnetic waves, there is periodic changes in electric and magnetic field which propagates through the space. These are the periodic changes in electric and magnetic field, and it propagates through the space. Thus, energy can be transported in the form of electromagnetic waves. Energy can be transported in the form of EM waves. Energy from the sun reaches the earth in the form of electromagnetic waves. So this is about the electromagnetic waves. Electric and magnetic fields are perpendicular to each other. It is also perpendicular to the direction of propagation. Now we see some characteristics of these electromagnetic waves. The characteristics are very simple. Characteristics of electromagnetic waves. As we know, the electromagnetic wave is produced by the oscillating electric charge. Oscillating charge produces the magnetic field. That changing magnetic field also produces the electric field. Here, characteristics are like this. First characteristic is electric field E and magnetic field B. Electric field E, denoted by E, and magnetic field B are always perpendicular to each other and also perpendicular to the direction of propagation. E and B are perpendicular to each other and perpendicular to direction of propagation. What it indicates? Electromagnetic waves are transverse in nature. We know the definition of transverse wave. Electromagnetic waves are transverse in nature. Electric and magnetic fields are perpendicular to each other. They are always perpendicular to each other and also perpendicular to the direction of propagation. Electromagnetic waves are transverse in nature. Then second characteristic is the cross product, that is E cross B. Electric field and magnetic field gives the direction along which electromagnetic wave travels. E cross B is another vector and it gives the direction along which electromagnetic wave travels. It also gives the direction of energy or energy carried by the electromagnetic wave. This cross product gives the direction of the electromagnetic wave and it also gives the energy carried by the electromagnetic wave. In this wave, electric field and magnetic field varies sinusoidally. That is, the changes sinusoidally. See, this is a sine wave. Electric field. Magnetic field also varies sinusoidally along the z-axis. Both waves vary sinusoidally and they are in phase, same phase. It means when this electric field is maximum, at the same time magnetic field is maximum, both are zero at the same point. E and B varies sinusoidally, that is, they changes sinusoidally, and also they are in same phase. Then next is electromagnetic waves are produced by oscillating electric charges. We know oscillating electric charge or accelerating electric charge produces the electromagnetic waves. If charge is accelerating, it produces the magnetic field. That changing magnetic field again produces the electric field. They regenerate each other, and hence we say that electromagnetic waves are produced by oscillating electric charge, or oscillating electric charge produces the electromagnetic waves. Characteristics are simple characteristics. Then see next characteristics of electromagnetic waves. These waves can travel through free space, that is vacuum. They can travel through free space as well as travels through free space. They can travel through free space as well as through solids, liquids and gases. They can travel through vacuum. Also, light from the sun reaches the earth. Most of the space is vacuum, so they can travel through free space. Also, they can travel through solids, liquids and gases. In free space, they travels with velocity of light. These waves travels with velocity of light, that is we denote it by c, in free space. We know velocity of light is very large, that is about 3 into 10 raised to 8 meter per second, and in free space its velocity is given by c is equal to 1 upon under root of mu 0 into epsilon 0. Electromagnetic waves travels in free space with the velocity of light, and its velocity is given by c is equal to 1 upon mu 0 into epsilon 0 square root of, that is 3 into 10 raised to 8 meter per second. What is this mu 0? It is the permeability of free space. This is a constant called as permeability of free space. The epsilon 0 is also a constant, that is the permittivity of free space. And its value is given by that equation, that is c is equal to 1 upon under root of mu 0 into epsilon 0. The value of mu 0 is 4 pi into 10 raised to minus 7 Tesla meter per ampere. 4 pi into 10 raised to minus 7 Tesla meter per ampere, and value of permittivity of free space is 8.85 into 10 raised to minus 12, 8.85 into 10 raised to minus 12 coulomb square per Newton meter square. So this velocity is same as a velocity of light in free space. This is the velocity of light or velocity of that electromagnetic wave. Now in medium other than the free space, velocity of EM wave is maximum in the free space. In the medium or in a material medium, its velocity is, next property is, characteristic is, in material medium other than the free space, velocity of electromagnetic wave in material medium is given by mu into 1 upon under root of mu into epsilon. Mu is the permeability of medium, and epsilon is permittivity of the medium. These are the constant. The next characteristics of electromagnetic wave is electromagnetic waves obeys the principle of superposition of waves. Principle of superposition. We know this principle. When two or more waves traveling through the medium arrive at a point of medium simultaneously, then each wave produces its own displacement independent of the other, and the resultant displacement at that point is vector sum of displacements due to all waves. These EM waves obeys the principle of superposition of waves. The next characteristic is the ratio of amplitudes of electric and magnetic fields. Amplitude of electric field is suppose E0, amplitude of magnetic field is suppose B0, that is the maximum displacement from the mean position. The ratio of amplitudes of electric and magnetic fields is constant at any point and is equal to velocity of electromagnetic wave. This is the amplitude of electric field, magnitude. This is magnitude of amplitude of magnetic field, and the ratio of these amplitudes of electric and magnetic fields is constant at any point and is equal to velocity of electromagnetic wave, that is C, and that is also equal to 1 upon under root of mu 0 into epsilon 0. So this is the next property. Then next property is, in these electromagnetic waves, the electric field is more prominent than the magnetic field. Very important property. Electric field E0 is more prominent than magnetic field. That is B0. Electric field is more prominent than the magnetic field. This electric field is responsible for optical effects. It is responsible for optical effects, that is effects related to light. E0 is responsible for optical effect due to electromagnetic waves. Hence this E0 is also called as light vector. In electromagnetic wave, this electric field E0 is more prominent than the magnetic field B0. Electric field is responsible for the optical effects due to the electromagnetic waves, that is the effects related with light, and hence this electric vector is also called as light vector. The next property is, intensity of wave is directly proportional to square of amplitude. Intensity of wave is directly proportional to square of amplitude. Intensity of electric field is IE is equal to 1/2 epsilon 0 into E0 square. 1/2 epsilon 0 into E0 square. E0 is the amplitude of the electric field. Intensity is directly proportional to square of the amplitude. Also, intensity due to magnetic field we denote it by IB, and this intensity is 1/2 B0 square upon mu 0. This intensity is directly proportional to this square of amplitude. E0 is the amplitude of the electric field, B0 is the amplitude of the magnetic field. These intensities are directly proportional to this square of amplitudes. And last property of these electromagnetic waves is, this property is also an important property. Energy of electromagnetic waves is distributed equally. Energy of EM waves is distributed equally between electric and magnetic fields. Between electric and magnetic fields. Energy, total energy of the electromagnetic waves is distributed equally between electric and magnetic fields. So this is about the electromagnetic waves, its production, and these are the some characteristics of electromagnetic waves. Okay, students, we stop here. Thank you.